Okay, welcome to the notes file for lesson 4.3. In this lesson, we'll be simplifying expressions. A key concept here, because we will be doing tons of this when we're solving equations, which is one of the most important 7th grade standards there are. So in simplifying expressions, this essential question here is how are properties of operations used to simplify expressions? And the wonderful thing about these property, remember we talked about them there, the commutative property, associative property, and our next lesson we'll be dealing more with the distributive property. But a wonderful thing about it is they allow you to do things that make things easier, and I don't want you to do a bunch of extra work in rewriting things, and we talked about that. The commutative property allows me to move terms around. And the associative property allows me to regroup things. When you do that, I don't really want you rewriting stuff showing that you move them. I just want you to know that you can move them, and we'll just show with a little bracket like what terms we are combining together. So let's quickly go through the vocab here. I'm not going to give you a big fancy definition here. The key thing, we've already defined equivalent expressions. They have to have the same value. So everything that we do in this lesson is keeping things the same, just making them simpler. They will appear simpler, but they'll have the same value. So a key idea here is everything we're doing, we are keeping the same value. So we're not changing the value of anything. We're just making it simpler. And a key idea when we're making it simpler is to put terms that are like terms, put them together. Like terms have to have the same variable in them. If a term has an x in it, it can be combined with other terms that have just an x in them. If a term is just a plain old number, it can be combined with other terms that are just plain old numbers. Like terms can be put together. If they are not like terms, we will not be able to combine them, which sometimes makes for little work that we actually have to do. We'll be adding and subtracting the constants and coefficients. Remember, this is just a reminder, a constant is a number, but it's by itself. So if a 5 does not have a variable with it, then it's a constant. If a 5 is in front of a variable, it's called a coefficient. So a coefficient, just a vocab term, a coefficient is a number in front of a variable. And when we are combining like terms, we're only going to be dealing with the numbers, really. The variables tell us which terms we could put together, but when we actually put them together, we only use the constants or the coefficients. We use the actual numbers, which means technically you can use a calculator, but your calculator, unless you have a very expensive calculator, it is not going to treat variables as variables. So when you go to type stuff in to check it, don't type in variables. You have to type in just numbers. So let's get into some examples of simplifying expressions. And again, each problem, if you want to give it a shot before I work it out, that'd be kind of a good idea. Just pause the video and then move on from there. So let's move into the first set of examples here. So in example 1, we're going to be combining like terms, but they'll have integer coefficients. So integers are whole numbers and they're opposites, so we can have negatives, but no fractions and decimals yet. That'll be example 2. So in example 1 here, we're going to be combining like terms with integer coefficients. It says a teacher used algebra tiles to model negative 2c plus 3c minus 5 minus 4c and plus 7. And so here's a picture of it. This negative 2c is represented by 2 negative rectangles, or 2 red rectangles here. The plus 3c, there are 3 green rectangles. Then we have minus 5, that's 5 little negatives here. And then we have minus 4c, and so there's 5 red rectangles. And then we have plus 7, and so since this is plus instead of minus, they use a different color. It's a 7 little yellows here. To simplify, it means we put all these things together. However, there's only certain amounts of work we can do. I can put C terms with other C terms. technically the commutative property says I can take these tiles and these tiles and these tiles and put them all together. I can move them around. I can do the same thing for these constants. I can take these little squares and put them with these little squares. Now what we're talking about in terms of the commutative property, I could move them around, but I don't think it's valuable to spend a bunch of time rewriting it doing that. How about we just show with some little brackets which ones we're going to put together here. So we are going to put together this one with this one with this one. So we're going to put together and I'll rewrite it, we have a negative 2c plus 3c, and then I'm going to rewrite the expression exactly the way, because I don't think there's a huge amount of value in spending time rewriting it. So I'm going to combine the c terms because they are all like terms. But when I'm combining them, I'm not actually messing with the variables at all. I'm just going to deal with the coefficients of these. Really, this is negative 2 plus 3 minus 4, and then I'll just put a c with it to say that I'm combining the c terms. So negative 2 plus 3 is 1. If we look up here at the visual, these two negative c's will cancel out these two, leaving this one green one. But then when I combine it with the minus 4c, it simplifies even further. So let's go through it again. Negative 2 plus 3 is 1. And then I take that 1 minus 4, and so I get negative 3, and it's c terms that I'm combining, so I put a c. If we go up here to the picture, we can actually see it. This red one and this green one would cancel out. This red one with this green one would cancel out. So these two reds cancel out two greens, but then this green one and that red one would cancel out, and we end up with 3 red rectangles, so there's negative 3c. And then all I do is I go and I pick the constants and combine them up. Well, we can get the visual here again. These 5 negatives will cancel out 5 of these positives. If we just go from the expression here, this is like a negative 5, and we can see that right there. Negative 5 plus 7. These 5 negatives will cancel out 5 of these positives, leaving 2 positives left over. So 2 of these yellow squares would be left over if I paired those up. So that's a positive 2, so I put plus 2. And then after you combine the like terms with the c's and combine the like terms with the constants, you have to be okay with that being it. Some people will try to go a little too far and they try to combine c terms with something that doesn't have a c in it, but those are not like terms, so that is it. If you wrote the constant part first, you could have 2 minus 3c. You could use the commutative property and switch those around. Either one of these forms is fine. One's not any better than the other. Most people will put the variable part first, but that's certainly not a requirement. So either form is fine. What's important is we combined the c terms together. I didn't have to rewrite it moving them. I just wrote it down as given, and then I use these little brackets to kind of show which terms I'm putting together. So let's take a look at this one here. This one, let's try it again. If you want to give this one a shot on your own, you're welcome to it. Just pause the video and go from there. When I'm doing this, I can only combine the terms that are alike. So I can only combine a constant with other constants. I can't combine this negative 6 with a term that has an f in it. I don't know what f is. I can't do that. So what I can do is I can combine this negative 6, a plus 7, and then later on there's a minus 9. So really I have a negative 6 plus 7. Negative 6 plus 7 is 1. And then minus 9. The sign that's in front of a number goes with it. So this is negative 6 plus 7 is 1. Minus 9 is negative 8. So I put the -6 plus 7 minus 9, and I get -8. And actually, if you think about it, you can just type that into a calculator. -6 plus 7 minus 9 equals. Key thing is, keep the sign that is in front of the number with that number. So you can't see this as a 9 here. This is -9. It's definitely not a 9. It's taking away a 9. And now when I combine my constants, I get -8, but now that I have those combined, I need to combine the f term here with the f term here. And we need to notice this is not 6, this is -6, or a -6f. And then this is not a 3, this is -3 or -3. So I would do that arithmetic as -6 minus 3. -6 minus 3 is -9, and those are f terms, so I put an f with it. And then that is it. I am done. Again, if you did the variable part first, you would get -9f, and then you'd put a -8 after that. This would be okay as well. Either form is one. So there isn't one better than the other there. So -6 plus 7 gave me 1. And 1 minus 9 is -8. Then I did -6 minus 3 and got -9. And I put an f with that one because I'm combining f terms, and so they are f. I need an f as my label there. So let's move on to another set of examples. These are going to have messier numbers. They're going to have fractions in them, but the same rules apply. In example 2, we're going to be combining like terms, but now we're going to have rational coefficients. So they could be decimals, they could be fractions. Doesn't change anything of our rules. The only thing that changes is there might be some more work involved in the combining, because if they're fractions, we'll have to get a common denominator if I'm doing it manually. If I'm typing it into a calculator, it'll do it for me. I'm going to show it without a calculator, so I'm going to be getting a common denominator and the like. I can use a calculator to check things, certainly. So example 2, we're going to be combining like terms with rational coefficients. The commutative property says that I could move terms around. It says that I could. I don't need you to rewrite it showing me that you did that. I just need you to combine the terms that are alike. And so I'm going to use my little bracket here. I'm going to put together this constant with this constant. They are both constants. There's no variable with them, so I can put them together. And this is a -3 and a -4.5 being added together. So a -3 plus a -4.5 is -7.5. And I can see, hey, they're negatives, so they're the same sign. They add up. 3 plus 4.5 is 7.5, and I stick that negative with it. And then I'm going to combine my variable terms, my x term here with my x term here. I can put those together. And I need to see, this is a positive 1/3 x, positive 1/3 x, but this is minus 1/5 x. It's not a 1/5 x, it's a minus 1/5. When I do the arithmetic, I'm going to do 1/3 minus 1/5. So if I go over here, 1/3 minus 1/5, to do this manually, I have to get a common denominator. So I'm going to do this problem here off to the side, and then when I put my answer here, I'm just going to stick an x with it. So 1/3 minus 1/5, I can't subtract them right now because they don't have the same denominator, but my common denominator would be a 15. 3 times 5. So I'm going to write this 1/3 as 5/15. And all that is multiplying both numerator and denominator by 5. Minus, and I'm going to do the same sort of thing here. The 1/5, to get a denominator of 15, I'd have to multiply both by 3, and I get 3/15. And now we have a very simple problem because they have the same denominator. I can just take 5 minus 3. 5 minus 3 is 2. My denominator is 15, so this is going to be plus, because it's positive 2, plus 2/15, and I just put an x with that. because I was combining x terms. When I did this arithmetic, I combined the x terms. And then that is it. I am done. I have a constant, I have a variable term. I can't combine those two because they are not like terms. So I looked at the problem. I saw there was a constant here, so I combined them. There was an x term here, an x term here, so I combined them. To do that combining, I made sure I saw this was a minus here, put that over here. I got a common denominator. 5 minus 3 is 2, kept my denominator 15, and there we go. So let's take a look at a couple of tries here. Again, if you want to give these a shot and then watch the video to see if you did them correctly, that's perfectly good, and in fact, a good idea. So if we look at try it 2, question A, we have m's, we have constants, we have m's, we have constants, we have m's. So the m's can all be put together. The constants can be put together. And so my answer is going to have an m term and a constant term. So if I put my m's together, I'm simply going to add those up. There are no negatives there at all, so I would just add up 59.95. And I'm just going to type this into my calculator so I can have a shorter video here. 59.95 plus, and again it's plus because right there's a plus sign, plus 7.95, and then plus 9.49. 9.49. So 59.95 plus 7.95 plus 9.49, and I get 77.39. But those were m terms I was combining, so I put an m with it. And so that part's done. The only other work I can do is I can put this term with this term. I can combine the constants together. That is not a 30 there. This is not a 30. This is a negative 30 or subtracting 30. If you want to type it into your calculator, you need to type it in as a negative 30. Or you can just think logically about it. If you take away 30 and then add 45, you end up 15 above. These 30 that were taken away will take away 30 of these, leaving 15. So this is going to be plus 15. So when you combine the constants, it's just negative 30 plus 45, which is 15, and there we go. If we move on to B here, if we look at choice B, we have a p term, another p term, and a third p term. I have 3 p terms. This problem ends up being quite a bit easier than you might think, because if we think about this right here, negative 0.5, this is negative 1/2. But then there's a positive 1/2, and I'm putting those together. These two terms, this p term here and this p term here, will actually cancel out. This is a negative 1/2, this is a positive 1/2. So when I put all 3 of them together, I'm going to end up with 2/3 p. And then another reason why this was pretty darn simple problem here, there's only one constant. And so that just goes along. I can't combine that negative 2.75 with anything because there are no other terms that are just constants. So there's the answer there. On either one of those, if you switch the terms around, like on this one, if the 15 was listed first, that's perfectly fine. Here, if you put the negative 2.75 first and then the plus 2/3 b second, it would be perfectly fine. As long as the numbers in front of the particular variables or the constants, their sign, as long as those things aren't changing, the order of the terms makes no difference whatsoever. So let's take a look at the last set of examples here. On the last set of examples, we're going to have 2 variables in it. That actually does not make it any more challenging at all. It just, I have to keep things separated. It actually ends up causing you less work to do because you can only add A terms with other A terms. You can only combine B terms with other B terms. You can only combine constants with other constants. So you can't combine it all into one thing. I can only combine an A term with another A term. I can't go beyond that. So on this particular problem, example 3, we're combining like terms with 2 variables. We're starting off with 4a minus 5b minus 6 plus 2b minus 3a. And as I look at that, I'm going to write it bigger so I can kind of combine stuff a little more clearly here. Minus 5b minus 6 plus 2b minus 3a. I can only do a tiny bit of work here. 4a can be combined with this minus 3a. You need to see this is not a 3a, this is a minus 3a. So if I ask you, hey, what's 4 apples minus 3 apples? That's not a brain buster. 4a minus 3a is just like 4 minus 3 with an a attached to it. 4 minus 3 is 1. A 1 in front of an a is just an a. So that's it. 4 minus 3 is 1. I don't really need to have that 1 there, so I'm going to leave it off. 1a is just an a, so there's no reason for me to put that 1 in front of it. The next thing I'm going to do here, I'll switch to a different color. I'm going to combine the b term here with the b term here. When I do that, I have to be super careful. This is not 5b. This is negative 5b. Negative 5b plus 2b. Negative 5 plus 2 is negative 3. These two positives will cancel out 2 of these negatives, but there will be 3 negatives left over. Negative 5 plus 2, when I combine the b terms, I get negative 3b. And then, nicely enough, there's only one more term. It's this minus 6. There are no other terms that are just constants, so I just put the minus 6 there, and that's it. A minus 3b minus 6. I can't combine this any further because this has an a, this has a b, and this doesn't have any variable at all. They're all unlike terms. You could actually tell just by looking at it. At the beginning, there's an a, b, and a number. You're going to have an a, b, and a number. Unless it's possible, like if this was a 4a and this was a minus 4a, that the a terms would go away altogether. But I can't combine a's with b's, and I can't combine a's and b's with constants. So that is example 3. So let's do try it 3 here. Again, if you want to give it a go on your own, pause the video and give this a shot. So I'm going to rewrite this a little bit bigger. So on try it 3, we have negative 3.7 plus 5g plus 4k plus 11.1 and then minus 10g. This seems kind of long and scary, but there's actually very little work that we can do on this particular problem because this constant, this negative 3.7, I can combine it with 11.1 because it doesn't have any variables either. So these two constants can be put together. And so if we have negative 3.7 plus 11.1, we get 7.4. When I put this negative 3.7 with 11.1, I get 7.4. And then here I have a g term plus 5g. And I look through here, here's another g term. This is not a 10g, this is minus 10g or a negative 10g. When I put a positive 5g, when I put this one together with that one, 5 minus 10 is negative 5. So I'm going to write that as minus 5g. And then the only term we have left is this 4k. It's been added, so it's a plus 4k, and I just bring this down. I can't combine that with anything because there are no other terms that have k's in them. And so this is my final answer here. 7.4 is what I got when I combined the constants. Negative 5g is what I got when I combined the g terms, 5 minus 10. And then the 4k was the only k term there, so I just kind of brought it down. If you have a rearrangement of this, as long as you have a positive 4 in front of your k term, a negative 5 in front of your g term, and your constant is a positive 7.4, it's good. So I could rearrange the terms, but the signs and the numbers in front of the variables have to stay the same. So if there's more than one variable, it actually makes it to where there's less work. Because if I use this, if there were a bunch of these that had the same variable, that's a lot of combining I would have to do. But we didn't have to do that here. Different variables make unlike terms that cannot be combined. So let's finish up this lesson here with kind of a summary. When you're simplifying, you're using properties. It says to simplify the expression below, group like terms, and it shows them actually being rewritten. And I really don't think that there's a ton of value in doing that. That is making a fairly simple problem much more complex. So on this example that's here, this y term can be combined with any other y terms. And so these two are right there together. I just need to see that they could be combined. I don't need to actually write it out as them being next to one another. I would just use a bracket to show I'm combining them. And then if we look at it here, we have an x term here and an x term there. Those two can be combined because I could move them together. But again, I don't think it's a lot of value in actually rewriting it. You're spending time rewriting it when you should just be combining the numbers. Negative 3.5 plus 0.53. And then the other terms we have here, we have a minus 3/8. Then we have a plus 5.25. That's another constant. Those could be combined. But then we also have a minus 12. So all three of these constants can be combined together. But again, I really don't think you should have to rewrite everything here. Just know I can combine all the constants together. So if you show me with these little brackets which ones you're combining, I'm okay with that. I do not need to see this rewriting. Just know that we could do that. And since we could put them together, I can mentally do that arithmetic rather than physically rewriting it. Then when you combine the like terms, it's just arithmetic. Negative 3.5 plus 0.53 is negative 2.97. Then we have 3/10 minus 2.75, and we get negative 2.45. And then we put all three of those constants together and you get that. So you should be able to go from here to here without doing all that business. You should not need to rewrite everything. Just know that you could do that, and so I don't want you to spend time doing that. I want you to spend time doing the appropriate arithmetic. So your homework for 4-3, it's 13 problems. You're doing 4 through 16 all. On each one of these, you're simplifying. So you're going to write down the term, and then you're going to be combining the terms that are alike. The order of the terms does not matter, but what does matter is that the coefficients, or the constants, the signs on those need to be appropriate. So if there's a minus 2k, you need to have a minus 2 or a negative 2 in front of the k term. If you're moving around it, that negative goes with it. So that is lesson 4-3. I hope these examples helped you. And as always, ask questions if you don't understand.